Okay, optimization. Optimization. Okay, guys, quit. So, this is what we need to know about optimization problems. I won't make you write it, but I'm going to read it. So, optimization is the process of determining the best solution to a problem. Often the best solution is the one that maximizes or minimizes the quantity. This is why this fits in this unit, right? Maximizing and minimizing the quantity. So an example, and I got these because you guys always wonder where the heck this fits in real life. So an example would be business owner's goal usually involves minimizing costs while maximizing profit. Or an engineer's goal may be to minimize the load on a beam. Or like a bridge, etc. Right? Load on the beam for a bridge. So, steps for optimizing the problems. You have to state what the variables stand for. You have to figure out what the heck you're maximizing. You're going to have to differentiate it. Because why are you going to have to differentiate it? When you differentiate the very first equation to get the first derivative, it will get you the what? Maxes and mins, which we're maximizing, right? And then you're going to find the absolute max or min. Which in this case, in some cases, you could use the second derivative. You're winning awards today, Podmore. You're winning awards. Okay, example 1. So this one I picked specifically because you can do it kind of like you did in grade 11. It's it's like the farmer word problems where you had to find the area of like a fence, and sometimes it was against a river and you didn't have to fence that in, or it was against a barn. So here's a question. So it's a farmer. You just laughed at the word farmer.
Absolutely hilarious.
My brother's farmers. A farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders a straight river.
Can I have it, please? Please.
You're done. Y'all done. I just had a minute heart attack. I literally am now over 40. I just aged a few years. Okay. If the farmer, and for those of you who just said she's not over 40, you're mean and rude, and you should think about it yourselves next time before you speak.
Maybe it was a statement, not
Does not fence the side along the river. The one that we need for this particular question.
It's an imaginary river.
Okay. So, what is the largest rectangular area that can be enclosed? It doesn't go into the river. Okay. So we have 400 meters of fencing. How we set this up in grade 11 is we would always say length and width. And we make ourselves a perimeter because that's what they gave us. The 4,000 is actually the perimeter. Yes, they wanted us to maximize the area, but they gave us the perimeter, correct? The amount of fence that I can go around the fence. So what is the perimeter when you have something against a river? length plus width plus length, or 2 lengths plus 2 widths, correct? However, this is a river, and we would like to let the cows drink some of it. Right, that's my straight, but that's water. That's flowing water. Visualize. Okay, so you're going to get to sweep my entire classroom. Because he's going like this with the rice cake on your desk. Because he's a toddler. Okay, so what do we have here to make the perimeter? Length times width times, length plus width plus width. I'm being distracted by the loud eating of the rice cake. I might have to ban some children from eating in my class. So what is the perimeter?
Yeah.
What's the perimeter?
4,000.
So we go 4,000 equals 2 widths plus a length. And then I'm going to solve for length. 2 widths plus 400. -2. And the reason why I want to solve for a length is because if I use area, which is the formula I'm going to need to use to maximize, right? So I need to figure out what do I need to maximize. I need to maximize the area because it's asking me for the largest area. If I want to maximize the area, I have to take the area formula, and I'm going to have to take the derivative of it. We agree? Well, it has a length and a width. So if I leave it as a length and a width, I'm going to have to do, first off, product rule. And then I'm going to have dl over dt and dw over dt, which I don't have any of those numbers, correct? But if I have them in one variable, then I'm okay. So you use the perimeter formula to isolate one of the variables. So I always isolate the L. And then area, that's what it has. Okay, area equals length times width. But if I left it like this, I would have to do implicit differentiation and product rule, which would not be fun. So I can replace the L with -2w plus 400 multiplied by w and distribute, so I don't have to use product rule. So I get -w squared, -2w squared, I'm really wanting to write 400, plus 4,000w. And I actually think when I did the notes, I think I put it as 400 at first. I did. It has 400. Oops. The whole, and then I switched it to 1,000 after. So smart. Okay. So the catch here is, in grade 11, you did all these exact same steps, but to find the maximum area, you completed the square. And then your back number, because it gave you the vertex when you complete the square, your back number is the y of the maximum or the minimum, right? We're not completing the square. It's easier for us now, because this is area. But if I want max area, all I have to do is what? Do the first derivative and set it equal to 0. Because when I have a horizontal tangent is where my max spins points of inflection are. So I'm going to go max area, or I could say a prime of w, technically, because I use w's, is -4w plus 4,000. And if I want the maximum, I just set the first derivative equal to 0. And then I can solve for w. So W is 1,000 meters, and it says, what is the largest maximum rectangular area? Well, area is length times width. I have width. I need, how do I get it? Put it into your length formula, the one that you got by itself. So length equals -2 times 1,000 plus 400. 4,000. I'm struggling with that. I don't know why. And so it's 2,000 meters. So max area equals 1,000, which is the width, times 2,000, which is the length, which is 200,000. That's a lie, 2 million meters squared. I'm just going to quit talking and just write numbers. So it's a large area. which it should be, because you have 4,000 meters of fencing. Like, that's a large area you can cover, especially when one side doesn't need to be fenced. So the questions to practice for this one are problem 3. And AP practice problem 4. This is 4.7. Okay, that's example 1. There are 3. So for that one, we maximized area. The next one, we're going to maximize volume. And the third one, we're going to maximize cost. So example 2. Nope. Could have used X and Y if you wanted to. What I should have done at the beginning, because I did a full out assumption there and I shouldn't have done that, I should have said let W equal width, let L equal length, let A equal area. I needed let statements and I dropped them. I didn't put them on. So you need let statements to say what the heck the variables are for. So like Shane said, could I use something different? Yeah, you could have said let X represent width, let Y represent length.
No, I was thinking like, could you isolate for length or?
W? Yeah.
Well, whichever one we isolated for.
Yeah, you would just get length then. And then you would have to put it back in to get width. Yeah.
Do you need a signal?
Yeah. So you need let statements. Because you always have to, if you introduce a variable, you have to tell them what it stands for.
So is the diagram not enough?
No.
They cannot contrast the things.
That would be a full assumption that they would know what your diagrams do.
Oh, okay.
Let A represent area. Let W represent width.
Do I have to represent?
No, you have to use, they use represent in all math.
You guys might have to represent what
You can write rep.
Do we have to use letters to let them represent stuff? We draw afterface? No.
Technically could, but please don't.
I'm going to do that.
So many bad things. Okay. So here we have from each corner, of a square piece of sheet metal. (18 centimeters on a side). You'll remove a small square from each corner. And turn up the edges. We did questions like this in 3-1 to form an open box. What are the dimensions of the box with the largest volume? This time it wants the dimensions. And largest is another word for maximum. So they're optimizing it. So if you can sketch something, the best thing to do is sketch it. So we have a square piece of sheet metal. And that's square. 18 centimeters on a side. they remove a small square from each corner, and you've seen this before, where they have like the dashed line. And then like this doesn't exist, right? And then when I turn it up, you'll actually have an open topped box, right? When you fold it up. Remember in 30-1 what we labeled X? These little cutout sides. This was an X, this was an X, which when I fold that up is actually the what? The height. Because when we want to do volume, we need length, width, height. Correct? In this case, it's side, side, and height, because our length and width are the same. Correct? So I have a variable, I have to let it represent something. So I go let X represent the height of the open box. Now what are we going to want to maximize? We want to maximize the volume. We agree? We want to maximize the volume. So the volume of a square box is going to be side is our savior. Who keeps hooking up to my Bluetooth device and playing stuff over it? Someone in this class.
What? A really good idea.
Let's not think of that first.
Hold on. Hold on. Actually,
It's Alexa. She had the cha-ching. You're not you, but someone gave you the cha-ching option. Who is hooked up to my Bluetooth device?
I want to get hooked up now.
It's Connor.
it's not me.
It's too hard to text in this class, guys. I'm not even maybe it's probably coming.
Start charging us for every hospital.
Yeah. Okay. So the height is X. Do not use the Bluetooth again. It's been used. It's been done. Don't try it again. So the height is X. The side length is what? It's not 18.
18 minus 2x.
18 minus 2x. And then how many times? Yeah, 18 minus 2x squared times x. So I can either do this two ways. I can either expand it and then do the derivative of it. If you do that, though, you're going to have to do synthetic division. Or you can do product rule and take out a GCF. And we'll be able to take out a GCF because our f in this case is, when I do f prime, it's going to be chain rule. Whenever I do chain rule, my second step is to be able to take out a GCF.
Oh no.
So I'm going to do max volume. So I'm going to do v of x, v prime of x, which is, we're going to find max volume. That's what we're going to find out of this. I guess I should just write v prime of x equals. So let's just solve it out. So we're going to get f, which is 18 minus 2x squared times g prime, which is 1, plus g, which is x times f prime, which is actually going to be, do it over here. So we're going to have 18 minus 2x squared, so you're going to get 2 bracket 18 minus 2x to the 1 times negative 2. So you actually get negative 4, 18 minus 2x. So we're going to get that over here. Negative 4, 18 minus 2x. So the GCF is going to be the 18 minus 2x, right? Because whatever one I can take, whatever one I do the chain rule with, I can take out a GCF. So I'm going to take out an 18 minus 2x. And then I'm left with 18 minus 2x in the first one. And then the back bracket, I'm just left with negative 4x. Because the 18 minus 2x goes away. And I'm left with 18 minus 2x. And then 18 minus 6x. And I can GCF them out, I totally can. But I just need to solve for them. I need to get the critical numbers of the first derivative, correct? And then figure out which one's a max or a min. How can I figure out quickly which one's a max or a min without having to do the chart? The second derivative test, right? Okay, so I'm going to go 0 equals 18 minus 2x. 0 equals 18 minus 6x. I get 2x equals 18, x equals 9. 6x equals 18, x equals 3. So I'm going to have to do product rule to get the second derivative, right? So v double prime of x is going to be f, which is 18 minus 2x. Do I need to actually simplify this one, though, if I'm just plugging in a number? I'm going to plug in 9, I'm going to plug in 3. Do I need to actually simplify this one? No. I can just go f g prime plus g f prime, fill it in. So f and then g prime, I'm using it from this one. G prime is negative 6 plus g, which is 18 minus 6x, times f prime, which is negative 2. And then I just need to plug in the 9, and I need to plug in the 3. This one you're going to get 18 minus 18, which is 0, so this side's going to cancel off. And then this one you're going to get a negative times a negative, which actually makes it be positive. So what would this one get you? A minimum. And then this one is going to be 18 minus 18, that cancels. And then this can be 18 minus 6. Which is 12, and then so it's going to be a negative, right? We don't really even care what the numbers are, do we? We just care what the answers are going to be, positive or negative. So what's that one going to be? This one's going to be the maximum. So we know the 3 is going to get us the maximum. Because we use the second derivative test, wherever the second derivative is negative, using the first critical numbers, it's a max. Where it's positive, it's a min. Now, that's great, we got that. But we need the dimensions. So I know x equals 3, which is lovely. But is that my dimensions? You go back to your dimensions. That's one of my dimensions. What is x equal to? The height. It is equal to 3. It is equal to 3. That is not an incorrect statement. Not where I was going, but yes. So x equals 3 centimeters. So the height is x equals 3 centimeters. How do I get the base length? So this is like problem 7 and 9. Hmm? 4.7 as well, yeah. Then we have one last big kahuna. Pay attention or you will be lost like a winter, yes, day blizzard that you can't see 1 centimeter in front of your face.
Let's just read it.
Wait. For the second last
But for the last, why is it 18 minus 2 times 3 instead of like the original volume equation that we got? Like the 18 minus.
It's 2x. What are you talking about? It is using.
Are you,
It's using it. I'm not asking for volume. I'm asking for dimension.
Oh.
If I wanted volume, you would actually plug it in. Yeah. Yep. Just make sure you use units. Okay. Big kahuna question. Example 3. So this is a cost question. Shh. I've seen this one appear a few times, so we're going to pay attention. So they want to minimize the cost. So we have a manufacturer needs to produce. All right, so faster. A cylindrical container with a capacity of 1,000 centimeters cubed. I don't use the proper T because then I confuse people because you guys don't know handwriting. The top and the bottom same with B's. Of the container are made of material that costs $0.05 per square centimeter, while the side of the container is made of material costing 3 cents per square centimeter. Find the dimensions. That will minimize the company's cost of producing a container. Okay, so we have to figure out what the heck we're minimizing. We're minimizing making the container. So do I care about volume? Does the volume make the container? No, what makes the container? Surface area. So I have to first figure out the surface area of a cylinder. So we were taught this, you were taught this in, yeah, a long time ago. Yeah. It's a square and 2 circles. It says the top and the bottom. Okay, so we have to get the area of 2 circles, so the area of 1 circle times 2. And then we have to get the area of a rectangle. However, it's using a circle. is not drawn probably to shape size, but whatever, you're good. Okay. So, what's the area of a circle? Pi r squared. So I know to make the surface area, it's going to be 2 pi r squared to cover the two circles. Plus, I need to get the area of that lovely rectangle. Now, how do I get this top? It's the circumference of the circle. Because if you take the circumference of the circle, you take that circle and you unravel it, boom. This piece here is actually, if you look down into the can, it would be the circumference of the circle, right? If I look down into the can, that's the circumference of the circle. I cut it down the middle and I unfold it. So circumference of a circle is pi r squared. Something area to me. If you need circumference, use pi d. But we don't want to use d's and r's. So if I use pi d, instead of d, I could use 2 r's. So it's actually 2 pi r. And then this is height. So I'm going to add the length times the width, right? So 2 pi r h. What's my problem again? Too many variables. I need to get rid of the h. So, what did they give me? I think they gave me volume, didn't they? They gave me the volume is 1,000 centimeters cubed. So I know 1,000 centimeters cubed equals the volume of that, which is pi r squared h, which remember they would give you that formula, the volume of the cylinder. Yes. I really wanted to say cone, but that's not a cone. Volume of a cylinder. Okay. So that's lovely. So in the other one, the very first one, I solved for L, so I could replace L and have just W's. I could have solved for W's. It would have been fine. This one I have to solve for what? H. There's more R's. Solving for R would just make it way more complicated. So I'm going to solve for H. So I'm going to get H equals 1,000 over pi r squared. And I'm going to fill it in. So I'm going to get 2 pi r squared plus 2 pi r 1,000 over pi r squared, which is actually better than it looks because the pi is going to cancel, r is going to cancel, and so I'm going to be left with 2 pi r squared plus 2,000 r to the negative 1. Why am I going to write it as r to the negative 1? Because it's a heck of a lot easier to do the first derivative. If I have r to the negative 1, I can use power rule. If I leave r on the bottom, I'm going to have to use quotient. Okay? Now that would be the surface area, which is great. But what do they want to minimize? The cost. So can I just minimize the surface area and say, call it a day? No, there's no cost in it. But we do know what each of those pieces cost, so let's do the cost. So if I take the surface area of 2 pi r squared, which is the top, what am I going to multiply by to get the cost? 5 cents. So 0.05. Plus, that's the center, which is actually cheaper to make, 2,000 r to the negative 1. I'm going to multiply it by 3 cents. And then I'm going to put them together so it's not nearly so. So I'm going to get 0.1 pi r squared plus 0.06. No, that's not true. What is this? What's 2,000? Maybe it is. What's 2,000 times 0.03? Is it 0.06? I question myself. R to the negative 1. 60?
Yeah.
Okay. I was like, that's not right.
Yes.
Well, no one's talking, and I'm like, I don't think it's right. All right.
So I had to use my
Well, it should be not smaller. It's 2,000 times 0.03. It made absolutely no sense as 0.06. That's what I was questioning myself. I think I had that written down. Oh, I put the cost in before I actually put in the H. That's why. I would get the surface area myself first. I wouldn't follow whatever I did on here. I would follow what I've done there. Okay, so what are we going to do? We have cost. We need to minimize the cost. So what do we need to do? Find the first derivative, set equal to 0, get a critical number. Correct? So, oh, I have to go, let's see. It's going to be really stupid for cost prime. Let's see. Equal cost. I'm going to go C of X. Represent cost. So I'm going to get 0.2 pi r. And then the negative drops in front, so I get negative 60 r to the negative 2. Right? Now it's harder to do critical numbers that way, so what I'm going to do is I'm just going to make that be r over the 2 and make a common denominator. So I'm going to go 0.2 pi r minus 60 over r squared. And then I'm going to multiply this one by r squared over r squared. So I'm going to get 0.2 pi r cubed minus 60 over r squared. It's easier to get critical numbers if you have entire numerator over entire denominator. And we're going to have that equal to 0. Now the radius of 0 is a critical number because it's in the denominator. I go r squared equals 0, r equals square root of 0, r equals 0. Does radius of 0 make any sense? It would minimize the costs because you would have nothing. You would have no shape. It would be the crappiest cylinder I've ever seen. So we're not going to worry about that one. We're going to worry about the top one. I've ever not seen, actually, because it wouldn't exist. Okay, 0.2 pi r cubed minus 60 equals 0. 0.2 pi r cubed equals 60. Divide by 0.2 pi. And r cubed equals 300 over pi. Because 60 divided by 0.2 is 300. And then I would cube root. When you cube root, you don't get a plus or minus. You get what it is, because you can cube root a negative, you can cube root a positive. If it's a positive, it comes out positive. If it's negative, it comes out negative. So we get the cube root of 300 over pi. Now, we should prove, which is approximately. I'll put an approximate. Approximate is the wavy little thing. It's not like some water, but it's an approximate. 4.571 centimeters. They want the dimensions that will minimize the company's cost. Now you should technically check that in the second derivative and make sure that the second derivative gets you what? A positive, so that's a minimum, right? Now to do the second derivative, I wouldn't use this. That would be quotient rule. I would go from here, right? So I would go C double prime of X equals 0.2 pi plus 120 r to the negative 3. And then you plug in that. So you get 0.2 pi C double prime. And you get 0.6 pi, which is greater than 0, so it is a minimum, which is good because it needs to be a minimum. If it's not a minimum, cry, because then I don't know what you're going to use. You did something really wrong. So that's our double check. So that's great. We want find the dimensions that will minimize the company's cost of producing the container. So I have the radius. Hey. What else do I need? I need the height, right? How do I get the height? Same way I got the length of the last one, the very first example. Put in here. Height equals 1,000. Do it in a different color so it doesn't blend. Oh my gosh. 7,000 pi, that lovely thing, cube root 300 over pi, because you don't want to round until the answer is squared. Now some people will say, well, what do we do if we don't have a calculator? Really? You think they're that nasty? They're not going to give you a calculator for this? Or they'll just take whatever you can reduce it to, right? Okay. So the height is somewhere on my page. 15.236 centimeters. So my radius is 4 I should use approximately because I rounded. Now what if they asked us for the cost? You have a cost equation. You have a cost equation. It's right here. It's this one. It's right here. Right? There's your cost equation. This one up here. Boom, boom, boom. You'll just plug your radius in, get yourself an answer. You have a cost equation, right? When you plug in your radius into the cost equation, I'm just going to write it here just in case you want to try it out, or they ask you and you know why. The minimizing cost is 1969. By just plugging it in for the R. It didn't ask for that though, it just asked for the dimensions. The questions like this, AP, there's problem 11 and AP practice problem 2.